Hello, welcome to this mini tutorial on surface area of 3D shapes. This is a particularly difficult problem which we covered in my Year 11 lesson this morning. I wanted to review it. We can see here the tunnel for a toy train. We have a 2D front elevation. Now this is the same on the front and the back. First of all, what we want to do is work out what shapes the surface area is made of. Now we have one of these on the front, which we can see there in the 3D image. There'll also be one behind on the back. So two semicircular shapes makes a full circle. As you can see, this is a semicircle with another semicircle cut out. If you take the front and the back, you have a big circle with a small circle taken out. Now we can see the big circle has a radius of 10. And the smaller circle, my drawing's not very good there, a radius of 7. So we need the whole of this. This would be the front and the back. Now, so it's going to be like a donut. A big circle, take away a small circle. And remember, we're doing this exactly in terms of pi. So, pi r squared. So we have 100 pi for the big circle, take away 7 squared pi, 49 pi for the smaller circle, which is 51 pi. So let's go over and put that on. That's the first bit. For the front and the back, I've got 51 pi. We might then want to consider the parts of the tunnel that are in contact with the ground. Now we're told in the text that the length of the tunnel is 30 centimetres. So it's always nice to add this on, 30 centimetres. So we've got two bits here. We've got two, I'll just draw them here. You've got two long rectangles which the tunnel sits on, which are 30 by 3. I know it's 3 because of this here. This measurement here, 3, tells me that's 3 there. So 30 by 3. So they're both 90. So I've also got 90. Just add that. What I've also got is a big sheet going across the top. Now, this bit will be just a big rectangle which is curved over. Now we know that it's 30 centimetres. Now this bit here corresponds to this bit here, which is half of the circumference of the big circle. The circumference is, of course, pi times diameter. We have a diameter of the big circle of 20, 2 times 10. The whole circumference would be 20 pi, so that's going to be 10 pi. So the sheet, if you like, which would make that curved bit at the top, would be 30 times 10 pi, 300 pi. So I've got a 300 pi there. I've also got a sheet at the bottom underneath. You see underneath there? I've got a sheet which will, I'll just draw this here. I know this is getting a bit messy. I'm trying to get it all on the camera. So that's going to be 30 long as well, just like the top sheet, but it's going to be based on that circle inside. So it's going to be, remember, the circumference is pi times diameter. That would be a diameter of 14, but we just want half of it, of course, which would be 7 pi. So 7 pi times 30, this would be 210 pi. So that looks like it's just about it. We've got the donut, which is made up of the front section, which you can see at the face. There's one of those at the back, gives you a whole circle. You've got these two bits here. We've got 90 and 90. Oh, I actually put just one 90 there. Two 90s is, of course, 180. 90 add 90, so that's 180 for the bits in contact with the ground. We have a sheet over the top there, which should be 300 pi. And then we have a sheet underneath, which is 210 pi. I add all these together. Well, the bits with pi is 51, 300, 210, 510, 561 pi plus 180. So the final answer is the surface area is 561 pi plus 180. Well, let's just recap. You've got the front, the same as the back, which gives you a donut. Not very mathematical term, but tasty. Now, you've got the two bits here, which the tunnel sits on, and you've got the two sheets. I hope that makes sense. Thank you very much.